Hi, my name's John. Welcome to another Sunday night nightcap. Next Sunday is the draw. There's quite a few names come in for next Sundays. I keep saying, if you haven't entered the draw, all you have to do is send me an email containing your name, your full name, like John Mills, not just John. Your name was into the bucket. There's a lot of names in here now. If it's drawn out, I'll post the prize off anywhere in the world, completely free of charge. Tonight's videos is all machining. I make a little tool to repair a weld defect on a race Volvo manifold. I make a start on making a lantern type tool post for a vintage lathe a friend of mine's restoring. I'm going to show you one or two of my dad's engines as usual. My friend Bob has dropped some fuel in for us, and one of my viewers has sent an old engine test stand, so hopefully I'll be going to get some engines running possibly through the week. I've picked out one or two that I'm going to run. I'm not going to run the boxed ones, they're too nice to run, but here's one or two that I'm going to try and get running. Anyway, I hope you enjoy the videos. This is a little engine test stand. I've got an NER engine on here at the minute, a little bit of fuel. I'm having problems getting the glow plugs to light up properly. It is trying, very trying. Right, that's enough of that. I'm going to have a proper play with it through the week when I've got a bit more time. But it is quite a nice little test stand that comes with a fuel tank and there's an igniter thing with it, so hopefully we'll get some engines running for next weekend's nightcaps. This is a highly modified manifold of a Volvo race engine. A friend of mine makes these manifolds. I supply these parts, he welds them in and modifies the manifold. What he's done, he's put a little bit too much heat in and he's actually managed to melt to the top of that. That's a bush where the injector goes. Now the hole in the bottom of there is 10mm, and the hole where the injector seal goes is 14. So what I propose to do is make a tool by putting a pilot into there. So that's going to keep the tool true to the bore, and I'll turn a bit of silver steel and ream it to be a nice sliding fit on there, and then sharpen the end so it can cut that out. I could just mount it on the milling machine using that, line it up and put a 14mm cutter through, but he's bound to do this again, and if I make a purpose-built tool, probably even just turn it by hand, it'll just take off because he has built up the aluminium where he melted it away. I'll get a close shot, have a look and see what's actually happening inside there. See where it's dropped down, a little bit too much heat. Easy to do with aluminium. It needs repaired. It'll take seconds to repair it, but there's a little bit of tool clown, a little bit of time in making the tool to do the job. And the first thing is to cut a piece of this to length, mark it and cut it, and then make a tool to do the job. That's right down to hitting his jig there. See, he does quite a few of these, that's why he's got a purpose-made jig. I have actually had to machine these flat for him after he's done them not using a jig, and they were a nightmare to mount, but he's obviously got the job sorted now. I'll mark that, and there will do. Cut that piece off and then find a bit of silver steel because we can harden and temper it. It won't really need it just to cut soft aluminium, but we might as well make a proper job of it. Right, that's the mandrel's going to go in there. It's a really nice fit. Now we need to find something to make a tool out of. Right, that's a nice piece of silver steel. I'll get one out of there. 50 mils enough. I'm going to part it up before I put the hole through it and ream it, because silver steel bars are quite expensive. Very slightly above. That's a fanny's hair below, which is where it wants to be. You've got a fanny's hair below or dead on centre height. Square the tool up to the job like that. We want 50 mil. If it's 60, it won't hurt to be a little bit longer. Tightening the headstock bearings up on this machine's absolutely transformed it. It did have a little bit of chatter parting off, but now it's not a problem. We got the actual cut part of this turned down to 14 mil. That's the hole size where the injector seating goes. People ask what speeds I run. That's 1,000. I do most of my turning at 1,000 RPM using carbide tooling. I think it's just 20 mil bar. Indeed it is, so we want 4 mil off that. Right, that's focus bastard features. That's dead on the money, 14 mil. Put the vernier clamp on as well. 1399, 14 mil. Next is to drill and tap it. Drill and tap it, is it? Next is to drill it and ream it 10 mil. I'm just going to take that little pip off the end. a slightly bigger drill in just so that it clears the chips better. You can go down a couple of gears as well. You can actually feel through the tailstock handle what's happening, and that's a happy drill. There's the swarf's coming out, no problem at all. This is a 9.5mm drill. It lives in the box with a reamer and gets used for nothing else but a reamer pilot. Reamers need to be run nice and slow and they like plenty of lube. And you only ever turn the reamer forwards, you never reverse the direction on a reamer. See the swarf there, it doesn't remove much. That's actually a 9.6mm drill, so it's taken 0.4, which is 0.2 to the side. Just about through. Right, we'll see if it fits. So that fits on the gate quite nicely, and it should fit in the hole as well. Lovely. So all we've got to do is sharpen the end of this so it'll cut that little bit of aluminium away. Not quite sure what I'm going to do with it yet, and I'll probably end up hardening and tempering it. Still a piece in the back of there to use the drill on possibly, not quite sure yet. Anyway, that's certainly going to do the job for him. I've put a shank in the end so I can drive it with a drill. I'm just going to sew that onto there. I've also sharpened the end. I've merely put it flat on, so that guide goes into there, that goes onto there, and that'll go around and it'll machine that little bit of weld build up out quite nicely. So I'm going to go up the shed now and sew that into there. At the same time we'll harden this, fully harden it, and then temper it back to make a nice little cutting tool. So I'll sew this in first and then heat the end up to a bright red. Quench it in water and that will make it fully hard. Then we'll polish it and temper it. Right, so now that's still warm. Right, the business end is glass hard, file won't touch it. So I'll take this away, polish it, come back and we'll temper it. Right, the idea now is to heat this up until the tip, that part there, starts to go a brown colour. We'll put the heat down here and you'll watch the colour slowly go up. Once it gets to brown, into the water. You could use oil, but I've got no oil up here, so what I'll have to do I don't know how well you're able to see the colour changing. See, it's the top where I'm interested in, but I'm putting the heat here and the heat will slowly go up the job. You see the colour start to go. And we're looking for a brown colour. So this is actually softening it, it's bringing the temper down. At the minute it's absolutely glass hard. You see the colours at the bottom. There's a brown colour there starting to go up, that's the one we want. Quite hard to see. And there's going brown there into the water. Right, see the brown colour on you, the very end, that's what we're looking for. Like a strawy to brown colour. And that'll be hard but not brittle, he hopes. Right, we're ready to give it a try. Then with a pilot. This goes into the drilling machine. Just going to move things around so you can get a better view. That's doing the job quite nicely. It'll not be the quickest cutter in the world, but it is going to do the job. Just use a similar cutter for pocketing 4-cylinder heads to put longer valve springs in years ago. Just a little bit left in the bottom there, just about done. Oh, it's absolutely gorgeous, that. Yeah, we'll settle for that.